Welcome to this Wise Owl Excel VBA tutorial. In this part of our series on writing SQL for Excel files, we're going to look at how to create basic subqueries. So the video is all about how to nest one select statement inside another select statement. We'll start with a simple example of using a subquery to mix aggregate values in the same select list. We'll then look at how you can add criteria to a subquery to limit the number of rows that it operates over. We'll then show you how to add a subquery to the where clause to create criteria. Towards the end of the video, we'll look at how to return multiple values from a subquery and how to handle that using the in, all, and any keywords. So let's get started. If you've been following along with previous parts of this series, you'll be fairly familiar with the basic setup by now, so feel free to skip ahead to the next chapter of this video. You won't miss anything exciting. Just in case you haven't seen previous parts of the series, here's a quick look at how things work. We have a macro-enabled workbook which allows us to run a query by clicking on this button, and when we do that it's going to extract some data from a separate Excel file called Movies. In this video the Movies workbook contains a single worksheet called Film. I've got both these files stored in the same folder, and I'll drop a link in the video description so that you can download both these files and follow along with writing the code if you'd like to. The code that's already in the basic Subqueries workbook relies on Microsoft ActiveX data objects, which isn't something I'm going to talk about much in this video. We've got a separate playlist which does cover ActiveX data objects, and if you're interested, I'd recommend starting with this video here, How Do I Get Data from a Closed Excel File Using VBA? Just to show the basics of the code in action, if I head back to the basic Subqueries workbook, when I click the Run Query button it triggers a subroutine called Create SQL Query. And all this subroutine does is constructs the string representing our SQL select statement. That then gets passed into a separate subroutine called getQueryResults, and this is the one that deals with the complicated stuff such as establishing the connection to the Movies workbook, extracting all the data into a record set, and this is the point at which our query gets used, and then the rest of the code simply deals with writing out that information into a new worksheet in the basic Subqueries workbook. So just to show the code working, we're going to select the title and runtime columns from the film worksheet in the Movies workbook, click the Run Query button, and that's exactly what we get in a brand new worksheet. For the first example, I'd like to compare the runtime for each individual film against the average runtime of all the films in the table to work out whether a film is longer or shorter than average. The first step in doing that is to calculate the average runtime for all the films in the table so that each individual row can reference the same value. Now if you remember the video we created earlier in this playlist on grouping and aggregating, you may remember that this isn't quite so simple as it first appears. Let's head back to the Visual Basic Editor and try to calculate the average runtime in minutes for all the films in the same select list that we currently have. A quick and simple way to do that is to copy and paste the reference to the runtime column into the select list, and then just wrap the avg function around the runtime column reference. Now you may remember if you have watched the grouping and aggregating video that this isn't going to work. If I head back to the menu sheet and I try to run this query, I see an error message saying that my query does not include the specified expression title as part of an aggregate function. So this is the problem when you have one aggregate function in a select list. SQL expects either every other column to also be aggregated, and if it's not, that column must appear in the group by clause. The solution to this problem is to calculate the average runtime in a separate subquery that's nested inside the select list of our main outer query. So to do that, at the beginning of this column, let's open a set of round brackets. Subqueries have to be nested inside their own set of round brackets. And now let's begin a new select statement. So I'm going to select the average runtime from the film table. So rather than write that out again, let's just cheat and copy and paste it from the next line down. So select the average runtime from the film table and then close a set of round brackets. So this is our subquery wrapped up in its own set of round brackets. And now that we've done that, if we head back to the menu sheet and we run that query again, we'll find that this time it does work and displays the same value on every single row, showing the average runtime of all the films in the table. The next step is to subtract the average that we've calculated from the individual runtime for each film, and that's nice and simple to do. Let's head back to the Visual Basic Editor, and again, just to avoid having to type this out again, I'm going to copy and paste the runtime column reference to the beginning of the line which calculates the average. I can then simply subtract the result of the subquery from the individual film's runtime. And let's assign an alias to the column so it has a sensible header. Let's call this something like runtime versus average. Okay, so having done that, we can head back to the menu sheet again and run the query, and we'll see a comparison of each individual film's runtime against the average runtime of all the films. We can take that same approach to create any calculation which involves the values for a single row and the value of an aggregate function. So for the next example, let's say we want to calculate the contribution that each individual film's runtime contributes to the total runtime of all the films. The first step would be calculating the sum of the runtime column. So let's head back to the Visual Basic Editor. We know we can't simply say sum runtime in a select list which doesn't have aggregates for all of the other columns, so the first step is to create a subquery which will calculate the sum of runtime from the film table. So again, I'm going to cheat and copy and paste the existing subquery, and then on the next line in the select list we can open some double quotes, type in a comma, paste in our query, and then close the double quotes and concatenate a continuation character to the end. I can then just change the function from avg to sum, and if I head back to the menu sheet and just run the query at this stage, we'll see a column that contains the total runtime of all the films. Now I can simply divide the runtime for the individual film against the total runtime of all the films. So again, back into the Visual Basic Editor, I'm going to once again copy and paste the runtime column, place that just in front of the subquery, and then divide the runtime by the results of the subquery. Let's just add an alias to the end again. Again, I'll copy and paste the existing alias from the previous line, and I'll call this something like runtime percentage of total. So having done that, if we head back to the menu sheet one more time and run the query, we'll see the very small contribution that one single individual film's runtime contributes to the total runtime of all the films. Next, I'd like to add a where clause to the query so that it returns only the Oscar-winning films from the list. Just before we add the where clause, I'd like to add an extra couple of columns to the select list. So let's head back to the Visual Basic Editor, and so that we can see we are indeed returning the Oscar-winning films, let's add the Oscar wins column to the select list. So I'm going to copy and paste the previous line and then say Oscar wins. I'd also like to display the average runtime from the film table. So I'm going to copy and paste the runtime column again, and then just below the runtime column, wrap that in a select statement. I could have copied and pasted all of this, of course, but I'm going to select avg runtime from film. And then don't forget to close the round brackets at the end of the subquery. Okay, so now that we've done that, we can head back to the menu sheet and just run that query again. So we can see at the moment we're returning films that don't have any Oscar wins, and we can see the average runtime of all those films. What I'd like to do now is add the where clause to show only the films with an Oscar wins value of more than 0. So we can head back to the Visual Basic Editor, and then at the end of the from clause, we can add a continuation character, and then in some double quotes add a where clause which will say where Oscar wins is greater than 0. So when we head back to the menu sheet and we run this query, one thing that's important to note is that although we have limited the number of rows returned in the main dataset, we're now only showing the Oscar winning films. That where clause applies only to the outer query. It hasn't affected the average runtime returned by the subquery at all. You can see that that value is identical to the value on the previous sheet. So if we want a criteria to affect both the main query and the subquery, we need to make sure that the subquery also contains the same where clause. So again, I'm just going to copy and paste the where clause that I've just written, and I'm going to paste that at the end of the existing subquery that calculates the average runtime for all the films, just to demonstrate. So I've made sure that I've done that inside the set of round brackets for the subquery, and if I head back to the menu sheet now, we should be able to see that the average runtime of Oscar-winning films is quite a lot different to the average runtime of all the films. So if we want our aggregations, our comparisons and contributions to the totals to operate on the Oscar-winning films as well, we should make sure we include the where clause in those subqueries. So I should still have this copied to the clipboard, so at the end of each of these subqueries I can paste in that same where clause. Just to tidy up, I'm going to get rid of the column which shows just the average runtime. That was just for demonstration purposes. And then if we head back to the menu sheet and run that query again, we'll see that the values, the comparisons of runtime versus average and contribution to total are now different because the rows returned by those subqueries are also different. Now, as well as including a where clause in a subquery, you can include a subquery in a where clause. Just to demonstrate the basics of that, I'm going to strip this query back to show just the title, Oscar wins and runtime minutes. So let's head back to the Visual Basic Editor. I'm going to take away these two additional columns, and then we'll take away the where clause as well. In fact, I'll just comment that out temporarily. So I'll just type in an apostrophe at the beginning of the ampersand on the previous line. Okay, so having done that, we can head back to the menu sheet and run that query, and we get all of our films back again. Now what I'd like to do is show a list of only those films that are longer than average. So to do that, I'm going to head back to the Visual Basic Editor. Let's bring back the where clause by taking away the apostrophe, and then change our where clause to refer to the runtime column. So I want to show only those rows where the runtime is greater than the average of all the runtimes, rather than the value 0. So to do that, we can create a subquery that calculates the average runtime. So just in the same way we've already done, we can select the average runtime from the film sheet. Okay, so having done that, we can head back to the menu sheet and run that query again. And we now get a list of all the films whose runtime is longer than the average runtime, which was 119-ish minutes. There we go, 119.65 minutes. You can manipulate the result of a subquery in the same way that you just manipulate the value that it returns. So let's say, for example, we wanted to show a list of films that were more than twice the average length of all the films. If we simply multiply the result of the subquery by 2, we can achieve that result. So back in the Visual Basic Editor, I'm going to wrap a new set of round brackets around the new expression I'm about to create, and just multiply the result of the subquery by 2. So having done that, if we head back to the menu sheet and run the query again, we'll see a much shorter list of films. So in essence, we're showing all the films whose runtime is greater than 2 times 119.6525. In the same way that you can include multiple subqueries in the select list, you can include multiple subqueries in a where clause. So let's expand on this example to show all the films whose runtime is longer than average and whose budget is bigger than average. Let's head back to the Visual Basic Editor, and I'm going to start by tidying up and getting rid of the multiplied by 2 additional part that we added there. I'm also going to change the Oscar wins field to display the budget instead. Then I'm going to modify the where clause. I'm just going to take the first criterion down to the next line, so I'll break this using a continuation character. And then I've got where the runtime is greater than the average runtime. And then at the end of that line, add a new continuation character. And then in a new set of double quotes, we're going to say and then refer to the budget column is greater than, and then we need to calculate the average budget from the film table. So let's just copy and paste the subquery, and then we can modify the average function to say, give me the average of the budget instead. Okay, so having done that, we can head back to the menu sheet, run the query again, and we'll see a list of all the films whose runtime is longer than average and whose budget is bigger than average. You can also include criteria which don't use subqueries in the same where clause. So let's say we wanted to limit this list to show only the Oscar-winning films again. Back in the Visual Basic Editor, we can add another line to the end of our where clause. So let's add another continuation character. And then we can say, and Oscar wins is greater than 0. I'm just going to include the Oscar wins column in the select list again as well. So I'm just going to copy and paste an existing line and then change the column name to say Oscar wins. And then if we run the query again from the menu sheet, we'll see we get only the Oscar winning films in the list. Now again, we've included this criterion in the where clause of the main query, but not in the individual subqueries. So at the moment we're showing a list of Oscar winning films whose runtime is longer than the average runtime of all the films and whose budget is bigger than the average budget of all the films. If we wanted to make this work so that we were seeing a list of Oscar-winning films whose runtime was longer than the average of Oscar-winning films and whose budget was bigger than the average of Oscar-winning films, we would need to include that same where clause in the two subqueries as well. So let's just copy and paste the Oscar wins is greater than 0 part, and then at the end of the first subquery, say where, and then paste that criterion in, and then do the exact same thing in the other subquery. So now everything matches, we can head back to the menu sheet and run that query once more. And now we're seeing the list of results that's all based on Oscar-winning films. Each of the subqueries we've created so far return just one single value, but it's also possible to create subqueries to return multiple values. To start demonstrating this, I'm going to change my query completely to show a list of films and studios which belong to a particular genre of film. So let's head back to the Visual Basic Editor, and I'm going to start by changing my select list. I'm going to bring the title field onto the first line, the select line first of all, and then I'm going to get rid of all of the other columns, so I'm not going to go for the budget, runtime or Oscar wins. Let's just delete all of those. And then in the same select list, I'm going to include the studio field. That will come from the film sheet. That's the only one available, of course. But I'm going to modify the where clause so that it only finds films where the genre of film equals the word awful. Okay, so I've written the word awful in single quotes there, as it's a string. Having done that, we can head back to the menu sheet, and some of you will already know which films to expect when we run this query. All the Twilight films, of course. Now, the point of doing this is so that I can return a list of any other films made by the studios responsible for the awfulness of the Twilight saga, to see whether that studio is worth saving, or whether it should be shut down immediately and banned from ever making any more films ever again. So the next step in this is to return just a list of the studio names. So let's head back to the Visual Basic Editor, and I'm going to change my query to take away the title column, and then we can also add the word distinct after the select keyword to return a list of unique studio names. So having done that, we can head back to the menu sheet and run that query again, and that returns our list of responsible or irresponsible, I think we should call them, studios. Now I can take that list of results and pass that into a subquery to find any other films made by these two studios. So to do that, we can head back to the Visual Basic Editor. This is going to become our subquery, so I'm going to wrap a set of round brackets around it. And then above that, I'm going to create a new select statement. I'll just concatenate the continuation character there. And I'm going to say select star or asterisk from film where the studio is in the list returned by the subquery that I've just created. So again, if you've watched previous videos, you'll know that if you want to compare a list of values against a particular column, you can't simply say equals. To compare a list of values, we could use a different operator. This time we'll use the in operator. I'm just going to indent my subquery lines to make that a little easier to read, I think. And if we then head back to the menu sheet and run the query again, let's see, so it looks to me as though Summit Entertainment might actually be safe here. Okay, granted they were responsible for the final Twilight film, but at least it was the final Twilight film, so they've got that going for them in the first place. But even better than that, they're responsible for some fantastic films here, so Memento, if you haven't seen it, highly recommend it, excellent movie. What else have we got? Now You See Me, that was okay. Escape Plan, not terrible. Gods of Egypt was pretty bad. Point Break, I haven't watched the remake, because why would you? How could you possibly top Keanu Reeves and Patrick Swayze? Impossible. And Hurt Locker's fantastic. John Wick, utterly brilliant. And 12 Years a Slave, also an excellent film. So I think Summit Entertainment are safe. Temple Hill Entertainment, on the other hand, I'm afraid it looks as though all they're responsible for is inflicting misery upon millions of people. So, yeah, I think they should be shut down immediately and banned from ever making any films ever again. So we've seen how to use the in operator to handle a subquery which returns multiple results, but we do have a couple of other options available as well. For the next example, I'd like to show a list of any film whose box office value is greater than all of the awful films. So we're going to first of all change the subquery to return a list of box office takings for the awful films, and then check if there are any other films in the database whose box office is greater than all of those values. So back in the Visual Basic Editor, let's change the subquery to first of all return the box office for all the films. The distinct keyword, we could leave the distinct keyword in there at this point, but it's not really necessary because the box office values are unique in this list anyway. So I'll take away the distinct and just say select box office. What we can then do is modify the where clause of the main query. So rather than checking for the studio, I'm going to check for the box office field. And I don't want to check if the box office is in the list returned by the awful film's box office values. I want to know if the box office of an individual film is greater than all of these values. I can't just say greater than, I need to say greater than all. So having done that, if we head back to the menu sheet and run that query, it might take a little longer to run than the previous one, but hopefully not too long. There we go. So there's a list of all of the films whose box office value is greater than the biggest box office of any awful film. So it looks like the most financially successful Twilight film made $829.7 million. That's obscene. So we're showing a list of films basically whose whose box office is greater than that. This is the equivalent. We didn't need to do it this way. We could have done exactly the same thing by doing something like this. We could have said show a list of all the films where the box office is greater than, not all. We could have made our subquery return a single result by wrapping the max function around the box office field. So having done it that way, we could head back to the back to the menu sheet and run the query again and get the exact same list of results as we got using the all option. We could do a similar thing to find a list of all the films whose box office is greater than any of the awful films. To get that to work, we could go back to the Visual Basic Editor, and again we have a couple of choices here. If we're going to use a basic aggregate function like we've used the max function, we could use the min function to return the smallest value of box office for the awful films, and then find any films whose box office is greater than that. So if we head back to the menu sheet and run that query, we get a list of all of the films whose box office is greater than the minimum awful films box office. Now bear in mind, because we're asking to show any film whose box office is greater than the minimum box office of an awful film, we are going to see some awful films in this list. So essentially we'll see all of the awful films except for the one with the minimum box office. We could of course exclude these ones just by adding some extra criteria to the where clause of the outer query. So we could say include all the films except for those whose genre equals awful. But that's relatively straightforward to do. We'll avoid that for now. The one final thing to mention then is that as well as doing it this way, there's a separate keyword we could use. So if we weren't using the min function to calculate the smallest box office of any awful film, let's just take away the min function. We could say show me any film where the box office is greater than any box office value returned by that subquery. This one takes a little while to run. If we head back to the menu sheet and we run that query by clicking the button, it'll take a little longer to run, or quite a lot longer to run in fact, than the one that uses the single value. I hope I haven't killed Excel here. That doesn't look promising, does it? It should return to life shortly. So you have these options, but if you have the preference, or if you have the choice, I should say, then using the min and max functions, so you're comparing the outer query with a single value rather than multiple values, is the preferable way to do things. There we go, we've actually come back to life. But we have the same list of results here as we had in the previous version. So there we go, there's the basics of using subqueries in your select statements. In the next video in the series, we're going to be looking at nesting subqueries to multiple different levels to help us answer more interesting questions about our data. So I hope you're looking forward to that one. Thanks very much for watching this one as always. See you next time.